Good afternoon. Thanks for staying with us. Thanks, Przemek, for introduction. And during this panel, we'll talk about the biggest mega trends in big data landscape. Those are, of course, open source technologies that might disrupt this landscape. This is also the cloud and different variation of the cloud, like public cloud, hybrid cloud, open source cloud, and private cloud, and also how those technologies help to implement better machine learning and AI projects. And let's start with open source first. So I analyzed the biggest trends in open source over last 7 years. And of course, the year 2013 was the best year for Hadoop. The next year was a big year for Spark. In 2015 and 16, Kafka became a mainstream technology. Year after that, stream processing with Flink, Beam, Dataflow became extremely popular. And last year, the year of 2018, was the year when Kubernetes really took off. So probably it's very early right now to make conclusions about the year of 2019, but I would like to ask my panelists what is their prediction about what would be the game-changing, the most disruptive technology in 2019, the one that everyone here should be aware of because it might change the way how they implement big data projects, how they build the platform, how they leverage those open source technologies in their projects.
So let me maybe start being Google representative and working in the IT industry for quite a while. I must dare to say that when it comes to predictions, human beings are extremely poor at it, right? So probably this is the reason why we are looking at artificial intelligence to help us with that particular part. So I won't dare to predict what's going to happen in the coming year. I can obviously tell what we as Google are putting the most efforts on with regards to big data and data science. So from that perspective, the thing that takes, I think, the substantial attention from Google is obviously Kubernetes that you've already mentioned, and how to make Kubernetes valuable to data science community. So for those of you who are not aware, last year we announced a project called Kubeflow, which is probably yet to come to Big Data Tech Conference as a separate topic. And this is one of the open source ideas to make containers more approachable from the data science or data engineer perspective. This is the project that we are investing a lot. It gathers a lot of attention also from the rest of the industry. So I believe that from Google's perspective, this is one of those ideas that I believe is going to grow significantly this year.
Andrzej, Rob, Fabian, can you add something?
I can only agree. I mean, the Kubeflow is probably one of the projects which will emerge this year. Especially the data science, machine learning is getting more and more popular. The second project, also based on Kubernetes, is kubeless. I believe that companies are going to invest more and more in serverless approach. Companies that were afraid about vendor lock-in, or they were in all data centers and couldn't use AWS Lambda or Azure Functions, for instance, now are able to take the serverless approach and go with it.
Sure. Okay, we'll keep going in a row at least. So I'm going to be the third person in a row to say Kubernetes, but maybe a slightly different take on it. So 2018 was the year that Kubernetes became a platform people realized they can run in production. This is definitely the future. But 2019 is then the fight of the other vendors, other software platforms to say they're the platform to run on Kubernetes. So lots of big data tools like Spark, they're getting there, but they're still not there yet. It's not really ready to run a production workload on Spark on Kubernetes. And the platforms that are able to happily run in production on Kubernetes will win by default this year because it makes you cloud agnostic, it makes you able to operate a hybrid cloud, those kind of things.
Yeah, so from the Flink perspective, again, Kubernetes is a fairly big topic. So the Flink community has been investigating for the last 1.5 years, basically to reinvent how it is working with resource managers, how it is doing scheduling on these resource managers. So we just had I think in one of the other talks, it was called the infamous Flip 6 effort, where we basically rewrote how we schedule tasks and bring up and use the resources. And part of that is also that we are significantly improved how we deal with how we can run on Kubernetes. We're still working on that, making like scaling, active scaling and passive scaling, basically being able to have a Flink job that actively decides, hey, I want to run on more resources, but also from the outside having some kind of like monitoring tool that figures out, hey, this job is not performing well enough, we need more resources, and then scaling it out. Another thing that is very important, or that will happen in this year in the Flink community, is really doubling down on the vision of unifying batch and stream processing. We just got a significant code contribution from Alibaba, so they contributed back their internal fork Blink to the Flink community. So we're working on integrating that, and this will bring us much closer to our vision of having a unified engine for batch and stream processing, unified in the sense of having one API for both, having one operator and execution layer for all of that.
Mm-hmm. And Fabian, do you think that Flink will be the first fully supported stream execution engine on Kubernetes? Or is it like... Well,
that is hard to tell. I think others are also working in this direction. I wouldn't claim we're the first ones. I think we're, of course, trying to make it the best one. I mean, who isn't? But yeah, not sure about the first.
Okay. Michał, why did Google decided actually to open source this project and make it so popular? Because as we know, it's backed by Google, and
yeah, so
is it a part of some strategy?
It's sort of philosophical question, right? So actually, to give you an answer, I prepared sort of experiment now, and to prove that this is not set up, I'm gonna invite audience to tell, right? So if out of the audience, if you can raise your hand, how many of you are using open source technologies on a daily basis? Yeah, that's what I thought. How many of you contribute to open source? Yeah, it's like 30%. That's even more than I actually expected. So you can see now, if you look at a company of Google size, right? So let's say, dozens of thousands of engineers, substantial amount of them are actually eager to share what they have actually built internally. This is actually what happens in Google, right? Most of those ideas deserve to be shared with the rest of the world, right? And it's a kind of rather discussion on the sort of a very high level, on the stakeholders level, what's the mission of the company, right? So besides actually running the business on a daily basis, there's also some sort of a vision how you shape the world. So just to shamelessly plug some quote with, big power comes great responsibility, right? So from that perspective, you also need to care about, the sustainability of the business, about how you impact the world that you're supposed to support, right? So I think this is, somewhere in the company's DNA to run the business together with the community. And if you look at the company's history, it simply worked. So if you look at all those projects that we are talking about over the whole day, most of them, or maybe significant part of them, were somehow influenced by what Google brought to the market. And it's not just about open source as a piece of code, but also about research papers or exchange of ideas that is coming either from Google or other commercial vendors. I believe this is the change in the market that happened over the last couple of years that helped data science, for example, become so popular, right? Without so active support coming from commercial vendors, probably we will not achieve the stage of AI that we currently have right now.
Okay. I personally think that Kubernetes is also like part of Google's strategy to help other users, other companies to choose where they want to run their computation analysis, whether it could be on-premise or Google Cloud or maybe different cloud. So with Kubernetes, it's very easy to go to the cloud, like Google, but it's also very easy to go out of the cloud. So maybe let's talk a bit about the cloud, about how it could be used by users, and also what cloud means to open source community, because those open source projects might coexist with cloud native projects, but they also might compete against them. So maybe Rob or Andrzej, what are the benefits of the cloud from your point of view, from the point of view of your company? Is it like the dreamland or something totally different? Like, what are the advantages or disadvantages that you see when talking about the cloud?
So I think the cloud is, in many ways, it's a no-brainer for us. There are obvious advantages. You can quickly spin up your development environment, your tooling is there, you can elastically scale to the workloads you need. We can see the clear technical benefits, and those benefits are only getting better over time. The cloud can develop quicker than our infrastructure can inside an organization. It's pretty clear that the cloud is, in a sense, the future. The only mitigating thing on this is, while the technical headwinds are for the cloud, I think it's happening right as the legal headwinds are kind of against it at the moment. So obviously Europe is tightening up its data requirements, its data laws, but also things like, so last year there was an act released by the American government called the Cloud Act. It's the clarification of the legal overseas use of data. It's actually quite a deeply scary act, and it's not that well understood, but basically any American cloud vendor, if requested by the authorities, has to release European data, even if it's on a European server. Whether or not this is a problem in practice for an organization like a bank, it actually makes moving to the cloud quite difficult, because that's actually illegal for us in the European laws. So certain things about the cloud are becoming more difficult right as the technologies are becoming perfectly aligned. So I think that's also going to be a really interesting challenge for 2019 here.
Okay, so I believe that there is a huge synergy between open source projects and cloud, and both Kubernetes and cloud solutions gives you one very important thing: freedom. Freedom to develop your system, freedom to scale, freedom to experiment. My team is highly using Azure machine learning compute just to be able to experiment with our approaches, with new models, with new ideas. We are able to run experiment on tens of GPUs, whether in typical data center it would take us a couple of days, whereas with Azure we are able to do it in minutes or hours. So it's really great. And yeah, I mean, probably we'll move this way, that cloud providers will support more and more open source projects. I'm looking for a machine learning or data science point of view, and it's a bit problematic. With typical engineering point of view, it's a bit better. I mean, we have Kafka in the cloud, which is almost the same Kafka as you can simply spawn on your data center. Whereas with data science projects and machine learning projects, it's a bit tricky at the moment. But it's getting better and better, and I believe that will be also the trend in this year, maybe next also.
Fabian, is Flink competing with Dataflow or not? Like how you see the future of Flink, assuming that more and more users will be using cloud, whether it's true or not, but what's your guess?
So no, I would not say we are competing with Dataflow.
Or other cloud-native stream processing engines.
Well, actually, Flink is backing quite a few of these services already. So there is Amazon in December released Kinesis Analytics for Java, which is essentially Apache Flink under the hood. Alibaba obviously has Stream Compute in China, which is backed by Flink. Yes, 2 days ago at the Mobile World Congress, they announced another product, Real-Time Compute, which is again backed by Flink. So Flink is running quite a few cloud services already, or it's been offered as a cloud service already. So from the perspective of the open source project, this is just great because somebody's just like providing your software as a service for everybody else who's like willing to use it. I think in the like last months there was like also a bit of discussion in the open source communities to what extent cloud providers should be allowed to use open source without contributing back. Mm-hmm. A few companies added or extended licenses for their projects. Like from the point of an Apache project, I mean, everybody you can just use the software, and also me personally, I'm very happy about anybody just offering this as a service. Coming back to the point of cloud data flow, I think everybody knows that, or many people know that Google started the open source project Apache Beam, which offers an interface to run batch and stream applications on different kinds of runners. One of them being Cloud Data Flow, one of them being Flink. And this has been like a very good thing for the Apache Flink community as well, because like the Beam community is continuously working on new features. They are now offering language SDKs for Python and Go, so you can run Python and Go pipelines on Apache Flink, and we did not even have, or the Apache Flink community did not even have to do anything for that. So this is just a great extension of like for what Flink can do or Flink can be used for.
Mm-hmm. Okay, so we already mentioned Kubernetes, Apache Beam. Those are the projects that came out from Google. There is also TensorFlow that you can run on-premise or in the cloud. So, Michał, like what could you give a comment on that? Because we see that Google has own cloud. Also, it contributed a lot to open source community. So, what is your vision like for users? What are the advantages and maybe disadvantages for users to use the cloud that you built at Google?
As I said, the whole company's mission is quite clear, right? We try to support community, to share as much as possible with the market and our users, because we simply think it's, first of all, it's right, and it helps also gaining the market share or brain share, right? Because as we all know, when it comes to open source, all those technologies come and go, right? So it's quite hard to keep an eye on all of them. So this is one of the, let's say, marketing efforts as well to help inject certain ideas to the market. This also happened, obviously, to TensorFlow. Luckily, we were the first ones to provide like a fully matured, deep learning framework to the market. So from that perspective, it's quite clear, as you said. It's all about multi-cloud discussions. Most of the customers, especially in larger countries, are already, to some extent, utilizing certain cloud vendor. We are not the biggest ones. We are still challengers. So we are trying to, first of all, focus on something that Google can provide the best. And also to be fair with regards to any sort of migration or hybrid approaches. And you can't do it effectively with locking your customers to certain technologies.
Okay, thank you. I'm looking at the app, and I don't see any questions from the audience. So you still have opportunity to write some questions that might be asked to our outstanding panelists. But in the meantime,
I may have a question.
Yeah.
Okay, to Michał. Let's start discussion about the TensorFlow. So I think the data science community or machine learning community doesn't feel open source community, doesn't have the feeling how to cooperate with other people and how to live with them. There is the whole idea behind Tensor Hub about sharing the ready state models. Are you going to develop this idea and force people to use it in some way?
Well, obviously not force people, but hopefully encourage them
Of course.
to share the know-how behind the models. Yes, actually, it's currently, I wouldn't call rebranded, but it's going to be a new release coming quite soon. So just have a look at what's called right now AI Hub. So that's going to be like a go-to place for anything data science related.
So those technologies are challenging also Hadoop and its core ecosystem. By core ecosystem, I mean HDFS, Yarn, Zookeeper, maybe a few other services. And how do you see the future of that stack of technologies?
So for us, I think the concept of Hadoop as this overarching stack is quite firmly dead at ING. You don't just take Hadoop, which means HDFS and MapReduce and all the supporting technologies anymore. We do it in a much more piecemeal way. So things like Hive are very, very much still alive. To my knowledge, it's the best metastore that we have available. And you can run a Hive database with S3 storage underneath it. That's totally fine. But we do find that, for example, I never want to see another MapReduce job as long as I may live. I think that can firmly be buried and replaced with things like Flink and Spark. So I think it just needs to maybe even rebrand itself. If we think of Hadoop as a whole, people will start declaring it dead before it really is. I think as long as we can select the individual components and then they're perfectly modularized so we can use them with other technologies, then it's got a future for sure.
Mm-hmm. Andrzej?
I think that it's natural that some technologies die and some are emerging. I remember that I used to use Samza streaming. I'm not sure how many of you have heard about it. Okay, obviously. But probably it will happen the same with Hadoop, probably. Same, we had so many relational databases. Nowadays we are using only few. Probably the same will happen with Hadoop ecosystem. Of course, there are some modules, as you said, that are probably crucial for companies, and they are very polished and working pretty well, and they will be still in use. But the whole concept probably will disappear soon.
Mm-hmm. So I think that there is a reason why we call Hadoop ecosystem and not technology stack, right? So this is not something fixed. And the market requires certain umbrella brands. So no wonder Google treats Hadoop, the original Hadoop, as an obsolete technology, right? And probably most of you as well. But again, I would not, just throw it out of the window just because, we need some brand new shiny name, right? So I would keep the ecosystem running, even though there will be new projects coming in, right? Because this is very natural to open source.
Mm-hmm.
Yeah, so again, from Flink's perspective, so we are trying to be compatible with lots of technologies. So we're not removing our Hadoop support anytime soon. But at the same time, we also realize that the technologies become more diverse. So we're, of course, trying to make our dependencies on other projects more modular. So you can basically pick and choose what you need. So we kind of removed all our Hadoop dependencies from Flink's core. So now you basically just have to add the dependency if you need it. So I guess that is something that we also learned. Don't bake in dependencies on other projects too firmly, and then you can just add more components more easily.
Mm-hmm. There is one question from the audience that might be related to what we talk about, like unification of batch and streaming, also simplification. Like, what about SQL? Do you think it's going to dominate a way to implement pipelines, stream analytics, and batch processing?
So I think SQL is very, very successful in doing or in making simple things simple. So I think this is really a very good use case. I mean, Flink has been working on unified or SQL interface unified for batch and streaming for quite some time now. So we obviously believe in this unification. It's of course not like the solution for everything out there. I mean, there's many streaming use cases that are not good fits for SQL, like all these microservice-like event-driven applications you probably don't want to or cannot even implement in SQL. But it's going to be, I think, makes a large fraction of what you would do with streaming a lot easier.
I'd say anecdotally, as a person who's currently trying to tempt a few 100,000 users away from their Excel spreadsheets, I like SQL because it's a nice, accessible way to bring all these users into the world of big data technologies. So for me, it's a very simple way of adding support for not just your data engineers and your data scientists, but your traditional data analysts or your business intelligence experts. It's to bring them into this single ecosystem. So for that reason, I love SQL and I want it to be applied to streaming workloads as well.
Okay, so we talked a lot about the platform, but let's move on to AI and machine learning. And I have a question to Andrzej, because his company is implementing a lot of AI machine learning projects. And how are those trends helping you to implement those projects? And are they good enough to do that easily, or it still requires a lot of effort to implement more sophisticated algorithms?
Of course, there is more and more open source projects around AI and machine learning, especially from big companies like Uber, like Facebook Research, like Google, Microsoft as well. And they are very, very good starting point just to create a benchmark. Sometimes it's also useful to use them developing more sophisticated models. Of course, there are libraries and frameworks like TensorFlow, which are super critical for the development of the whole community around machine learning, data science. And as I said, the problem is that machine learning people are not to use cooperate in open source ecosystem. We need to put a lot of effort to pushing such approaches like AI Hub, as you said, which is crucial for us as well as our company. Usually we are using open source projects to develop our machine learning solutions. We also contribute, at least try to contribute to models, especially because the problem is that usually you have a paper with no code and no explanation how to implement the project. So it's crucial for the community to push good implementations of the particular models and help also other companies to use those models, preparing them in proper way. We learn how to describe and prepare open source engineering projects, software engineering projects. We are not fully ready to describe and prepare open source models, not frameworks for machine learning, but particular models, and that's quite challenging for us.
Okay, and how is Flink putting big effort to make it easier to run machine learning in real time on top of that?
Well, not yet. So I guess Flink is not known to be very good at providing machine learning or AI solutions. But this is going to change in the future as well. So part of this unification of batch and streaming will also be to invest more resources and more effort into being good at machine learning and AI. In the meantime, we can also again leverage what the Apache Beam community is providing by offering this Python API. I've already seen demos where they plugged in TensorFlow into these pipelines and then basically run parts of the TensorFlow pipeline on Apache Flink. So yes, in the future, Flink will also put more effort on machine learning, but we haven't started yet.
Okay. How about Google Cloud?
Yeah, so it might be a little bit controversial, and this is definitely my own personal opinion on that. I believe that we are definitely at the very infant stage of the whole AI, as an industry. If you look even at the sessions during this conference, we are trying to resolve really basic stuff, like, for example, how to serve effectively the models, right? Or how to share information between the scientists. By the way, even the scientists, a lot of companies have hired PhDs to become data scientists, and what they are actually doing, they are actually not scientists, but they are scribes. As you said, they are trying to decipher certain research papers, trying to code something instead of inventing new things. So I'd definitely love to see in the future, hopefully soon, new uncovered territories for AI. Because to be honest, I'm participating in a lot of conferences, and I'm a little bit bored seeing yet another, image classification or image recognition or video stuff. There are a lot of other areas that are simply untouched yet by the science or research. And this is hopefully an area that the greenfield that we'll be chasing soon.
Rob, anything to add from your side?
Sure. I think probably anecdotally, again, from ING, I think our biggest problem with putting data science models into production is actually a scalability challenge, because the kind of common answer to a data science is Python, and people are using the most famous libraries off the internet, and typically these aren't built with scalability at the forefront of their minds. So the data science in a box component I was talking about this morning, I got asked this week, can I spin up one of those with 20 terabytes of memory? That would involve probably going to someone to build us a supercomputer that we can host this one pod on. So they're trying to run these models that don't naturally scale on massive data volumes and hitting issues. So yeah, I don't know what the answer is to that, but I think our libraries need to be built with scalability in mind. The common things like XGBoost and things like that typically are still focused on one node.
Okay. We don't have much time left. I see interesting question from the audience, because during the conversation we focused on this year actually. But let's not focus on this year. How big data landscape, like on-premise, cloud, open source, is going to look in next 10 years? Can you imagine that future? Can you see some really big trends that might... Yeah. This was the question.
I can try some high-level things with the crystal ball.
How do you imagine like analytics, big data at ING in 5-10 years?
Yeah, so we have to answer the cloud question. In 10 years, we definitely, I hope to say we will be in the cloud and the legal landscape will be clarified and all will be wonderful and we can scale to our heart's content. But I would love for that not to be proved wrong. I think the other thing is, at the moment, data science is a bit of an elite art. It's like everyone's like, they will try to solve all problems with AI, and there's a massive backlog, and we can fill our current set of data scientists with work for the next 100 years. So I think in the next 10 years, that will be democratized. There'll be ways to bring AI into more and more things we do. But in itself, I'm sure there'll be some challenges there, because there are frameworks to auto-tune models, auto-recommend the model that you should use. But unless you really understand the features you're putting into a model, it could give you the perfect result for that data, but it's completely useless in the real world. So I think there'll be some sagas around that across the next 10 years.
And
so very interesting project, machine learning-based project. Again, image recognition. It was possible to draw a mock-up of a website, and AI was creating a code, HTML code of the website. How cool it would be to draw an infrastructure and have an cloud, for instance, infrastructure, and have it prepared by AI and some coding. Maybe something like that, or
sign me up for that one.
Or create data pipelines and have it done by AI.
Yeah, so something I'm quite sure about is that SQL will still be there. So
for sure,
it's just not going away.
So the only prediction I have is most likely data scientists will not remain the sexiest job of the century anymore. So just be aware of it. I think that the democratization is becoming the reality, right? And this is yet another IT job that might become boring for some and interesting for some others. So it's just usual, business as usual.
Mm-hmm. Okay, I think that our time left. So I'd like to thank you for your answers. Thank you for the audience for being us and asking this final question that nicely concludes our panel. And Przemek will take a stage.
Thank you very much, Adam, for hosting the discussion.